In this video, the learner will solve problems using central angles and inscribed angles of circles. First, let's talk about arcs of a circle. We've talked about the definition of an arc before. We can actually measure arcs of a circle in terms of degrees. So if I have an arc of a circle, arc AB, I'm going to measure this arc using my protractor. Notice that the protractor is actually curved to match the edge of that circle. And we can see here from 0 to 83 degrees, we can measure that arc in terms of that angle that it creates. Now, what is the total number of degrees in a circle? I want you to answer that question. First, we're going to talk about central angles. This is an angle with its vertex at the center, and the sides are radii of the circle. So P is the vertex of this angle. It's also the center of this circle. And RP and QP are both radii of this circle. Now, the relationship that a central angle has is that central angles are equal to their intercepted arcs. So whatever that arc is, that central angle is going to be equal to it, and vice versa. So we have this example here. I want to find the value of x. So notice x is at the center of the circle. That means we're going to be measuring this central angle GFJ. We're given that central angle GFH is 130 and central angle HFJ is 90. We know that the three of these angles should add up to 360. So we'll replace GFH with 130, HFJ with 90, and then we're searching for GFJ. Add like terms and get 220 plus our missing angle equals 360, subtract 220, and so central angle GFJ is 140 degrees. Okay, I want you to try these two examples. Solve for x. Now we're given here that GJ is a diameter of circle K. Being a diameter means that K is the center of that circle. We're going to identify each arc as a major, minor, or semicircle arc, and then find its measure. So GH is this arc of the circle. GH is a minor arc because it is less than halfway around the circle. So the measure of arc GH is the same as its central angle GKH that intercepts it. So that would be 122 degrees. For arc GLH, GL, and then all the way around to H, is that major arc that connects G and H together. So it shares the same endpoints as our minor arc, but it is on the other side of that circle from the minor arc. Notice it is more than halfway, so it's a major arc. In order to find the measure of that, we have that central angle that's a reflex angle on the other side of this 122 degrees. We know those two angles are supposed to add to 360. So 360 minus the measure of arc GH will give us the arc GLH, which is going to be 238 degrees. Okay, I want you to try these examples with circle R. Next, we're going to talk about inscribed angles. This is an angle with its vertex on the circle and sides that are chords of the circle. So we can see this circle here. M is the vertex of this angle, and notice it is on the circle. MN and ML would be chords of the circle because their endpoints are both on the circle. Inscribed angles are going to be half of their intercepted arcs. So whatever arc LN is, angle LMN will be half of that. So find each measure. We have the circle here. We have chord MP, chord PN, and chord NO that create the inscribed angles, angle MPN and PNO here. So for the measure of angle P, the measure of angle P is going to be this inscribed angle here. Notice that we are given that intercepted arc of MN. Well, we know inscribed angles will be half of the intercepted arc, so measure of angle P is going to be half of arc MN. So half of 70 is going to be 35 degrees. The measure of arc PO, notice arc PO is here, and it is the arc that's intercepted by the inscribed angle PNO. If we're given the inscribed angle, we know that had to be half of that intercepted arc. So we know that the arc is going to be double that angle. So 2 times 56 is 112. Okay, I have this circle here that I want you to find arc CF and the measure of angle C. To answer the following: what would be true about two inscribed angles that intercept the same arc? Try drawing this out and seeing what you come up with. And what would be the measure of the inscribed angle if one of the sides of that angle is a diameter? Again, try drawing this out and seeing what you come up with.